Good morning to one and all present over here. Today we're going to see about zinc oxide eugenol cement. Coming on to introduction, zinc oxide eugenol cement have been used extensively in dentistry since the 1890s. It is most widely used temporary restorative material. So coming on to composition, it is generally available as powder and liquid. So powder consists of zinc oxide 69%, which is the principal ingredient, and white rosin of about 29.3%. It reduces brittleness of the cement, and zinc stearate acts as accelerator and plasticizer. And zinc acetate, it also acts as accelerator and it improves strength. And magnesium oxide, it is added in some powder, it acts with eugenol in a similar manner. And coming on to liquid, it consists of eugenol and olive oil. Eugenol of about 85% and olive oil of about 15% acts as plasticizer. So coming on to properties, biological properties, it offers better biocompatibility and least irritating than the rest of the dental cements. When inserted into the cavity, it has approximately neutral pH of 7, whereas all other cements, zinc phosphate and zinc polycarboxate, has an acidic pH. They are the least irritating of all cements. Pulpal responses are mild and they have soothing or abtendant effect, that is nullifying or sedative effect on exposed dentin and pulp. So coming on to other properties like compressive strength, it is relatively weak cement. It ranges from a low of as low as 3 to 4 megapascals to about 50 to 55 megapascals, whereas zinc phosphate it has a very high compressive strength of about 1 or 4 megapascals. And coming on to tensile strength, it's about 0.32 to 5.3 megapascals, and modulus of elasticity is 0.22 to 5.4 gigapascals. It lacks resistance to wear, and thermal properties, it is a good insulator. And solubility and disintegration, the solubility is highest among the other cements of about 0.4 percentage weight. And they disintegrate in oral fluids very easily. Okay, so coming on to properties, if you see, it has a very good biological property, whereas when coming on to mechanical properties, it has the least mechanical properties, that is compressive strength or wear resistance or solubility. Everything is compressive strength is being low, and thermal properties is also, it acts as a good insulator. But coming on to wear resistance, it's very low, and solubility is very high. So coming on to adhesion, they do not adhere well to the enamel and dentin. This is one reason why they are not often used for final cementation of crowns and bridges. And coming on to bactericidal effect, antiseptic effect on microorganisms remaining in dentin. Eugenol is bactericidal at high concentrations of 10 power 2 to 10 power 3 moles per liter, but high concentrations might be toxic to pulp. And coming on to sedative effect, at low concentrations, eugenol acts as a local anesthetic. It decreases intradental fluid activity, minimizing the sensitivity to hot, cold, or sweet. Also inhibits neural conduction and anti-inflammatory action. In low doses, it causes resolution of mild inflammation. It inhibits neutrophil function and chemotaxis and removes harmful free radicals like superoxide, which are generated by these cells. Coming on to classification now. It is of 4 types. Type 1 is used for temporary cementation. Type 2 is for permanent cementation. Type 3 zinc oxide eugenol as temporary fillings and thermal base. And type 4 as cavity liners. And is being available as we have already seen, powder and liquid or two-phase system. So coming on to setting reaction, in the first step, hydrolysis of zinc oxide towards hydroxide takes place. Water is essential for the reaction, where dehydrated zinc oxide will not react with dehydrated eugenol. Okay, the reaction proceeds as a typical acid-base reaction, where zinc hydroxide reacts with eugenol to form zinc eugenolate and water. The chelate formed is an amorphous gel that tends to crystallize, imparting strength to the set mass. Structure of set cement consists of, that is, a set cement consists of particles of zinc oxide embedded in a matrix of zinc eugenolate, and setting time is of about 4 to 10 minutes. So coming on to factors affecting the setting time, coming on to particle size, smaller particle size of zinc oxide sets faster, and powder to liquid ratio, higher the ratio, faster the set. Addition of accelerators like alcohol, glacial acetic acid and water makes the cement set faster, and cooling the glass slab slows down the reaction, and the set can also be retarded by addition of glycerol and glycerin, which acts as retardants for this reaction. And coming on to modifications of zinc oxide eugenol, so to improve the working properties, handling and setting characteristics, we have the partial substitution of, so why do we need this? Because eugenol causes irritation on most of the people, okay, most of the individuals. So that's why we have the partial substitution of eugenol by orthoethoxybenzoic acid and addition of fused quartz, aluminum oxide and resin polymer to the powder component. Thank you.